Wow. Okay, so we have 3 more examples left. First one. Write equation of tangent line to f of x equals x cubed minus 5x plus 1 for f prime equals 7. Okay, so this is actually more like what we did yesterday. So, or actually not yesterday, the day before. So what 2 things do you need to write the equation of a tangent line? 2 things.
Point slope.
Good, point slope. Point. Okay, point and slope. Now, did they give us a point this time?
7.
Is that a point?
Derivative.
That's the derivative, which makes it the...
Slope.
So I know my slope is going to be 7. So remember, we did these yesterday, but with horizontals. Okay, so if I want the slope to be 7, I'm going to go about doing it the same way. What would I do first? Take the derivative. What's f prime of x if it's this? 3x squared minus 5. What about the plus 1? Okay, that's my derivative. What do I want it to be equal to? 7. So I would let 7 equal 3x squared minus 5. And then go about and solve, just like yesterday. But instead of being horizontal with a 0 slope, they're asking you to have a slope of 7. So add the 5 across, we'd get 12. Then what?
Yeah, divide by 3.
Yep, what will we get? 4?
So x is equal to plus or minus.
Okay. Let's say that we have x greater than 0, just so that we can pick one instead of doing both. Okay, let's say we're picking positive 2. How would I get the y value for the ordered pair? Plug in where?
The original equation.
Original, very good. So you'd find f of 2 would be 2 cubed minus 5 times 2 plus 1. What's 2 cubed? 8 minus 10 is negative 2 plus 1? Negative 1. And then we remember how to write, hopefully, the tangent line. Y plus 1.
Equal to 7.
Uh-huh.
X minus
Good. Very good. Okay, next one. Number 2. Remember, we only have 3. We're almost done. Okay, this one you're going to need your calculator for. So it says, find x value where f of x equals ln x plus 2 is parallel to 4y plus 2x equals 8. Okay, so first thing, what do you already know about parallel lines? What do they have to have in common? The same what?
Slope.
The same slope. So now calculus that. Slopes are derivatives, then their derivatives have to be equal to each other, yeah?
Say that one more time.
Okay, so parallel lines have the same slope. And remember that in calculus, that means they have to have the same derivative. So our game plan would be to take the derivative of both functions and then set them equal to each other. Okay? So, first thing we're going to do is take the derivative of this one. Hopefully we remember ln x has a rule. What is the derivative of ln x? 1 over x. Very good. Okay, now look at my line. It's all jumbled up, but we can fix it. Okay, 4y equals, we got to get y by itself. I take the 2x, move it across. Now it's negative 2x plus 8. Then what? Yep, by dividing. So y equals negative 2 over 4 is a half x plus 8 divided by 4 is 2. And now that I have it in y equals form, I can take the derivative. So what would y prime be for this one? Negative a half. And remember, when you were in Algebra 1, you also, for a line, you know it's y equals mx plus b. If that's the m, that's the slope anyway. Okay, so that should be consistent with what you remember. Then from there, if I need them to have the same slope, I'm going to take this formula, this slope, I'm going to set them equal. And actually, I guess we really don't even need a calculator for that. Okay, you're always allowed to just flip both sides. So if it's 1 over x and I flip it, what would I get? X over 1. Negative 1/2, flip it, what do you get? Negative 2. And then you just don't even need your calculator. Okay, let's do one more. I'm going to pick it off the homework assignment that you would have had if I had it. Okay, we're going to do... We're going to do number 1. Okay, so I'll write it down on my notes for you. Okay, so you're going to find the point. Where f of x equals x squared minus 3x is parallel, last example, to y equals x plus 11. Okay, so first thing, what do we know if they're going to be parallel to each other? Their slopes have to be the same, but slopes are the same as the derivative. So take the derivative of both, set them equal to each other. So what is the derivative of this top part? 2x minus 3. What's the derivative of the bottom part? 1. Okay, and then from there we're just solving. So take the 3, add it across, you get 2x equals positive 4. X is 2. Okay, now it said find the point. Where do we get the other half of the point? Original or line? Original. So you would take f of 2. 4 minus 3 times 2 is 6. Negative 2. Okay, now, same question, but now we're going to find where f is perpendicular to the line. Okay, so think about what changes. What is f prime still? This is not changing. F prime would still be 2x minus 3, right? But if I want to be perpendicular to this slope of 1, how do you change the slope? Instead of using 1, you'd make it
0.
not 0. Remember, this is 1 over 1. So how do you make a perpendicular slope to that? You flip it, still 1, but what else do you change? The sign. So it'd be a negative 1. So remember, you'd have to change your slope to be perpendicular. Change to perpendicular slope. And remember, that's always flipping it and then changing the sign. Then from there, what would I do? Still add the 3 across and get what?
2.
2x equals 2. Then divide by 2 on both sides, x equals 1. Okay, so think about on your graph, if you were to graph that, okay, and then you have your straight line here, x plus 11 would be up here. What it's saying is that at positive 2, your graph is exactly the same, versus at 1, your graph is perpendicular. Okay? So just to kind of graphically connect those dots. But algebraically, you're taking the derivative, setting it equal if it's parallel. You're setting it equal to the opposite reciprocal if it's perpendicular. Okay?